Let's begin our Chapter 4 review by evaluating a couple of determinants. Recall that on the first diagonal you multiply normally, and on the other diagonal when you multiply upward, instead of writing -8 you change the sign to +8. Now we can add those two values together to get 20. So the value of that first determinant is 20. The second determinant I'm going to solve using my shortcut method, where I bring out the first two columns and then I begin the multiplication of all those diagonals. The first diagonal, -4 times 6 times 0, has a 0 in it, so its product is 0. The next diagonal, 1 times 8 times -1, has a product of -8. Then -3 times 5 times 2 makes -30, and adding across the bottom we get -38. Multiplying up in each of these diagonals, the first diagonal, -1 times 6 times -3, makes 18, but we change that to a -18. 2 times 8 is 16, times -4 would be -64, but we change this to +64. And the third diagonal has a 0 in it, so its product is 0. And adding across we get 46. 46 plus the -38 down to the bottom is 8, and so that is the value of this 3×3 determinant. Now we are being asked to solve this equation, and we really have any method to choose from, but because this second equation has y isolated on the left, I'm going to choose to use the substitution method to solve and substitute in y into that second equation. So we now have 5x minus 2 times x plus 1 being substituted in is equal to 10. So 5x minus 2x minus 2 after the distribution is equal to 10. And we have 3x on the left. I will bring the 2 to the right to make that equals 12. And x will equal 4. Now you need a y value to go along with this, but you know that y is x plus 1, therefore y will equal 5, and your solution is the coordinate point 4, 5, which can be checked in both of the equations to verify that it is indeed the solution. For this next system, we do not have x or y isolated, so we probably want to use the addition method. I notice that 4 and 2 are a nice convenient set of numbers, so I'm going to keep the top equation as is and multiply that second equation by -2 so I can eliminate the x's. So the first equation is just going to get brought down. 4x minus 5y is equal to 19, and the second equation will get multiplied by -2, giving us -4x minus 6y is equal to -30. And we've designed it so that those x would cancel each other out, and we have -11y is equal to -11, and dividing each side by -11 we have +1. Now we need a value for x, so I'm going to substitute 1 into that bottom original equation, and that gives us 2x plus 3 times 1, which is 3, is equal to 15. Subtracting 3 on each side, we have 2x is equal to 12, and therefore x is equal to 6. And so our solution is the coordinate point 6, 1, where these two lines intersect. For this next problem, we have a choice. We can either clear the fractions by multiplying through by least common denominators, or we can just go straight to substitution because we have an x equals. And that's going to be my choice here. So I'm going to take this second equation, substitute it into x in that first equation, and that will give us 1/3 times 3/2 y minus 11 plus y is equal to 7/3. Now, when I multiply the 1/3 by the 3/2, these 3's will cancel, leaving us with 1/2 y minus 11/3 plus y is equal to 7/3. And we probably would like to clear the fractions right now by multiplying through by the least common denominator, which is 6. That will give us the following: 3y minus 22 plus 6y equals 14. Combining like terms, we have 9y equals, and I'm going to write this as 36, adding 22 to each side, so y is 4. Now I want to substitute that 4 into one of these original equations to find x, and I choose right here because I can get x equals 3 halves times 4 minus 11. You couldn't see that. I substituted into the second equation. I'm going to cancel here to get 2 times 3 is 6, so x will equal 6 minus 11, and therefore x equals negative 5, and our solution is the coordinate point negative 5, 4.